This question is a higher grade question, but this could well appear on foundation. It's a bit of a crossover topic, this. And you can see that what it's asking is, it states that the diagram shows a trapezium ABCD and two identical semicircles. The centre of each semicircle is on DC. Work out the area of the shaded region. Give your answer to three significant figures. Okay, so there are a number of stages to this. The first stage that I'm going to do is I'm going to work out the area of the trapezium. Okay. Those of you that I've taught, you will know that I sometimes remember this or teach this by a nursery rhyme, and the nursery rhyme is to the tune of Pop Goes the Weasel. And as you may laugh, but it actually works and it actually helps. Okay, and so the nursery rhyme goes something like, half the length of the parallel sides times the distance between them. That's the way you calculate the area of a trapezium. Okay. I know I have no shame, so I'll get over it. So basically, as it says, half the length of the parallel sides. So that means that I'm going to add the parallel sides. So 28 add 12, and then I'm going to halve them. Okay. And then I'm going to multiply that by the distance between them, and the distance between them is 14. So the area of the trapezium is going to be 28 add 12, which is 40, divided by 2 is 20, multiplied by 14, which is 280 centimeters squared. Okay, so that's the trapezium. The next step is to work out the area of the two semicircles. Now, a really useful thing to notice here is that they're both identical, they're both semicircles, so actually what you've got there is a circle. Okay, in terms of the amount of area, the amount of space it's taking up, it's just the same as a circle. You can see that as it meets halfway, that the diameter, of this is going to be 6, which means that the radius is going to be 3. Okay, so what I've got for the second part is the area of circle. Now, I'm really sorry I don't know any nursery rhymes for this, but the area is pi r squared. Now, the radius, as we said with this, is going to be 3. So it's going to be 3 squared is 9, so it's going to be 9 pi. Okay. The question says, work out the area of the shaded region. Now, you'll notice, by the way, just to say, at the moment, I'm leaving that as 9 pi because once I evaluate it and give an approximation, that could affect future calculations within the problem. Okay, so I'm going to keep it like that to start off with, and then we'll just see how it comes about. Okay, so the final bit of this then is to work out the area of the shaded bit. Now, obviously, the shaded bit is a trapezium with the circle taken out. So it's 280 minus 9 pi. Okay, and that is the shaded area, which is the bit that we're looking for. So on my calculator, 280. Oops, not divide. Sorry, subtract 9 pi, and that gives me an answer of 251.726. But the question says to three significant figures, which in this case is going to be to a whole number. So the answer is going to be 252 centimeters squared, because remember, we're looking for an area. So it's going to be 252 centimeters to three significant figures. Okay, so as with so many of these questions, what you need to do is you need to read them very carefully and work out exactly what it's asking you to do, and see if there are any little shortcuts or anything that you can do that will make it easy, such as recognizing that the two semicircles are in fact half a circle each, so they come together to make a full circle. Okay, hopefully that's helped. Like I say, that could appear potentially in both foundation and higher, but this particular question I've pulled from a higher paper. Okay, so that's that. Okay, please Any questions, please leave comments on the video. If you are a record producer and you'd like to sign me up because of my beautiful singing voice, then please do. That'd be absolutely fantastic. But all joking aside, I hope that helps. And if you get that little nursery rhyme stuck in your head so that it helps, then making a fool of myself was well worth it, okay? Okay then, guys, right. That's it for now. See you soon. Bye-bye.